Hello, everyone. Welcome to our live stream conversation with Peter Terwiesch on our LinkedIn and YouTube accounts. The topic of today is our journey towards autonomous industrial operations. I'm Shai Davidovich, and with me, as I said, Peter Terwiesch. Peter is the president of ABB Automation Business Area and a member of our executive committee. Hi, Peter. Morning. Good afternoon. Good evening for everyone who's joining us. I see people on the chat already joining us from all over the world. Welcome, and thank you very much for already participating in our conversation in the comments. Please let us know where you are from, which industry you are part of, so we can get to know you a bit better when we start. Peter, you've been with ABB for 30 years now?
Yeah, 31 and counting, actually. So I joined in '94 on the research side of the house, and have since then basically been on the R&D side and individual contributor. I've had different management roles in there also, all the way from leading projects to chief technology officer of the company at some point. And then on the business side, my career is a bit back and forth, and I've enjoyed that very much. Understanding technology and what it can do, understanding customers and what they will need, and then basically building that bridge from both ends. So I've been a local automation manager in Switzerland, in Germany. I've had global roles. And yeah, I'm now 11 years leading our automation business, which is a real privilege.
Impressive background. Thank you very much. I'm looking at people in the chat right now. I'm seeing quite a lot of people. I see people from India, from the Middle East, Latin America, as it seems from the languages here. Welcome, everyone. The phrase autonomous industrial operations might sound like something out of a sci-fi movie. You might picture in your head a factory, running in the dark, machines quietly humming in the background, and everything ticking along without having any human on the floor. But there is a thing. Autonomous industrial operations aren't about technology taking over human beings. They are about augmenting human expertise and automation, of course, where AI, automation, and digital technologies play a significant role in basically creating a layer of intelligence that helps, among other things, of course, to see some patterns, to predict issues, and make better decisions in the end of the day. And it's already happening today, more than you might even think. And we're going to hear from Peter today more about that. So the conversation is not about the hype around that, but more about what's happening right now and where this is all going. As we mentioned, we are doing a live stream right now, so we do want to hear from you throughout the conversation today, what you think. If you have any questions, any remarks, if you agree or disagree with anything we're saying, please write them in the comments. I will try to take a few of those and bring it to Peter and hear from him a bit about what he thinks about that, and maybe help clarify a few points for you. And I see people are joining us right now. We have almost doubled the number of people as we started, so I'll just reintroduce Peter. Peter Terwiesch is our president of ABB Automation Business Area, is a member of our executive committee. And if it's okay, I want to dive right in, Peter, to my first question. You're coming from an engineer background, also, as we heard from you in the opening. And I want to take you a few years back. Okay, when did you first start working on technologies that are linked to autonomous industrial operations?
I think it's hard to pick a specific date, but I studied in the '80s system dynamics, automatic control, already actually self-funded my studies working as a programmer. So I had a lot of exposure to software when that was still a newer thing than it is today, obviously. And then really after studies in this area, after a PhD on nonlinear dynamic process optimization, I joined ABB Research in the mid-90s. And we were then working on the first generation of systems that would be digital systems that would be more dependable than the individual subsystems, than the components they were built of, because these systems could self-diagnose, self-heal. So I wasn't looking at it as a step towards autonomous at the time. But if I look back, I think it effectively was sort of my first ABB connect to this topic. And it's been with me in different constellations ever since.
Why was it important back then?
I think it was important because we were trying to keep infrastructures, critical infrastructure running 24/7 when, in computer science, if you look at your computer, You make a service agreement, you go like, yeah, what do I need? 99% reliability. That's pretty demanding. Can we do that? But in critical infrastructure, you're talking about 99.9999. So 6 nines is like a typical requirement of what you need. And there may be applications where it's even more. So that's really something that is critical for our customers, for them to operate in a safe, sustainable, and productive way. That's what they need in much of their operations.
I think for people like me who might not understand a bit about where it is, we are hearing a lot of conversation, of course, where things are going. It's not a secret. In the last at least 2, 3, 5 years, we are hearing a lot of conversations, of course, about AI. But before we get into the future, can you please maybe walk us through how it has evolved? I mean, talking about from the past, you mentioned the 90s, from early days until now.
Yeah, and if we go like to the really early days, I mean, ABB, we've been in automation for many, many years. Like I at some point, oh yeah, thanks for the slide here. I mean, I went at some point myself actually to the company archives because I'm quite interested in the history of technology. And this gentleman who's on the picture over the 1890 label, he's truly in a hydropower plant that ASEA, as one of our ancestors, had done at the time. And you can see, you can count the number of objects you see on the screen. So there's about a dozen signals, inputs, a dozen outputs. And you could see what a single operator could basically handle and digest. And if you then fast forward nearly 100 years, it's not only that people got color screens and we saw some aberrations of what you can do and should or shouldn't do with color, but you actually also saw a large number, like tens of thousands of signals in a concentrated operation. I think this particular one is from Central Europe in the petrochemical sector. But they were pulling all these signals together. And so with far fewer people could master complexity that was previously totally unheard of. So I think from the perspective of the gentleman on the left, this was a huge step in terms of doing things with process they couldn't imagine at the time. And then if you go from there, and in those days, there was already this vision of the lights out factory, this vision of things that completely produce by themselves. But it was by and large unrealistic. Technologies were pretty awkward. If you look at the kind of floppy disks we had at the time, the memory, you were doing things with ingredients. I mean, moon landing was done beforehand. So with a lot of effort, you could do certain things, but it was very limited. Whereas I would say today, roughly speaking, we're in an age of collaborative operations. So we've moved from just automation towards what I call collaborative operations, and it's collaborative in multiple ways. You have people who work across discipline boundaries. So for instance, the operations people with the maintenance people work on the same data and information with different interests and views, but they synchronize using the systems. You have different locations, so people work across locations. That was COVID, for instance, accelerated that a lot. Suddenly we had places where we needed to be. We had people who had expertise but couldn't travel there. There were other people maybe closer who could go there. And suddenly we needed to do a lot more collaboration. And technology was actually ready and it worked, which is still amazing. And now I think we're increasingly in different paces, different dialogues, but across a broad range of industries looking at how can we advance the frontiers of autonomous industrial operations. So that's what this is about.
You're talking about the impact on people. You mentioned a bit about that. Can you talk a bit more about the impact, the benefits for industries, and of course, mention people, a bit more about that?
When you look at benefits, I think you always come back to safety, productivity, and sustainability. When we say at ABB, we help our customers outrun leaner and cleaner, this is safety, productivity, it's sustainability at the end of the day. So it's about doing more with less. And one of the ingredients is you keep people out of harm's way. You keep them away from work that is dirty, dull, and dangerous. If I give you examples there, if you take underground mining for more than 10 years already, we've been working with a customer who's been a technology pioneering partner with us there also, who are operating an underground mine. And one of the potentials in there was that instead of people always going down, drilling holes, putting explosives, evacuating out of the mine in order to do the actual blasting and then go back in, and all the consequences this has on moving around people, material, ventilation, and so on, actually separating the people from the rock face into an operating room, you get much better conditions for people. You get people out of harm's way. So yes, it's safer, but it's also hugely more productive because you can actually keep continuously producing as opposed to have these permanent interruptions out of going in, evacuating back out, running ventilation cycles differently. So it's a huge potential for safety, but at the same time productivity. And there's also clearly sustainability. When you use less energy on the ventilation, that's a big part of what you need in the mine. On the underground side, then it helps. So that's been in operation successfully for more than 10 years already. And they wouldn't be there if we hadn't jointly, the customer and ourselves, succeeded in making that work.
Sure, sustainability, very important aspect also for ABB. We're trying to follow all the comments you're putting in the chat. I see people joining literally from all over the world right now. Indonesia, Egypt, KSA. Hello, everyone. I see a lot of Latin Americans right now. Yes, early morning there right now, if I'm not mistaken. I want to ask you a bit about levels of automation, because we're talking about very different levels of automation. Can you explain a bit more what it means?
Yeah, basically, it's not a binary, like either you have autonomous operations or you don't. But I think if you look at the car industry, they've inspired us really to find a language with our customers to look at what is it between the needs and the technology capabilities, and where do we make the right trade-offs, because more isn't always better. In other words, if you want to go in the stack that you see on the screen all the way to level 5, that comes with a lot of effort. And at the same time, it also comes with potential downsides. So if you look at the autonomous car that gets talked about so much, and maybe I start there with calibrating the stack. With the autonomous car, there's a sense that, oh, I've taken a ride, say, with a Waymo cab in San Francisco. Autonomous operations is there in the car industry already. Mm-hmm. Until you actually dig into it and look into, is the car really operating autonomously? And when you go look for more details on how it's working, you actually find the car goes by itself for a couple miles, but then runs into an interesting intersection with some complexity. There's unforeseen things, and the car then basically goes, ping, I need a person to support me remotely and take me through this complexity. And then there's a person interfering with the operation until the car then runs by itself again. Mm-hmm. So in a strict sense, the vehicle is actually not autonomous, even though it's kind of not having a physical driver in it. And so even in the automotive industry, where there's a sense in people that, oh, they're on level 5 already, what I have seen sort of with actual technology isn't actually a level 5. It's like a 3 trending for 4. And I would say probably by what I know about this industry, we see some 4s there, but we're not actually at 5 yet. So one of the things we have using the chart you see here is a dialogue with our customers to look for their specific industry and application. What's a sensible level for you, and what benefits can we, in a sense of leaner and cleaner, achieve if we go from the level where we currently are to the level we would be targeting? And at the same time then look at what would it take to go beyond that, and then analyze at where's the optimum, like where's there still an attractive return, and where are we simply automating and heading for autonomous just for the sake of it, but not promising the returns anymore.
In our comments, someone by the name of Pita was asking, what about accuracy in automation operation and decision making? How is it assured?
Accuracy depends very much on the application, how important it may be. I think if you're, for instance, stockpiling in the minerals industry, then you got a different sense of accuracy compared to when you're docking a vessel in a port where ultimately you have to be precise. So different industries have different sense of accuracy in terms of location and time. And you need to start with having the right sensors for that, but then also how you tune your control algorithms, and the degree then to which you would allow artificial intelligence systems to get into the loop. You only really want to do that if you find them dependable and trustworthy. Otherwise, you can use them on a consultative basis, but you don't want to use them in closing loops. So that all is part of what we discuss with customers when we look into specific applications.
We are kind of exposed in the last, again, a few years for a lot of news innovations from different companies. As you mentioned, some of them are more autonomous than others. Some of them seem autonomous, but might not be from the behind the scenes, what we as users are experiencing. What are the realistic milestones? I mean, we're looking at the next few years that you can predict or you can assume that we are going to see happening.
Again, I think it's a picture industry by industry. And if I use, say, container ports, which is also one of the industries that we serve, it's quite amazing how that has evolved. And you can see this visually. If you go look at an older port, you see container cranes that have crane driver cabins on them. And basically the job was to basically climb this crane, maybe 50 meters above ground, sit in this cabin, hot, cold, vibration, and not so easy to have a coffee break from there. And it's a pretty rough job. Sort of what we could do with automation, with remote control in the first place, was to actually move those workplaces to operator rooms where you could do, let's say, roughly the same job with a joystick. Mm-hmm. And then you could go and take the next slice out of it and basically say, well, there's parts of the container operation that can be done by the crane itself if you augment what the automation does. So you move it from just automation in the direction of more autonomy for like the easier part, the level 3, level 4 kind of things. And then suddenly you have an ability that one operator can look after more than one crane, because some of them may be during a routine thing that you can automate. Yeah, exactly. Here you have it. So we move from what I studied in feedback control, the sense, analyze, act, the feedback loop, and of course also the feed forward sequence programming, which is things that human beings are not that great at. Like if you ask me to do 300 steps every day, the same exact ones, I'd be challenged, but I could program a machine that would do it every day, even if I didn't sleep that well last night, perhaps. And here, then basically the perceive, understand, solve is the next level of feedback loops, and it depends very much on this industry, on the perception, for instance. Do you need live video and processing of that? Do you need natural language processing? Do you have new types of sensors that you didn't have, spectral, for instance? And then same thing with understanding. How do you digest this information? And if you look, artificial intelligence, for instance, has progressed a lot, understanding natural language, so that, for instance, an operator who's out in the field can query a system and both get the information of what's the temperature on trade 22 of this distillation column, which the control system will know and can tell him, as well as what's the availability of spare parts for this pump, which is starting to make noises that I'm not really comfortable with, as well as then solve in terms of, have we had this kind of situation before? Like, I've only been working here 5 years in this particular plant. But if we have data from the last 25 years of operation, somebody's probably had the same situation. So can we do a root cause analysis based on initially pattern matching and then sort of drilling deeper, interrogating the system? So I think these are all ways where you still have human beings in the loop, but it's a much wider loop than the traditional feedback control loop we grew up with.
This fits with the question that we see within our chat with Aniket. And basically the question was, are there any sectors where it's appropriate for AI to take over more than others?
I'm always careful with AI taking over. I think it's humans using technology to do the job better. And I think when we right now talk about AI, it's shifted from like a few years ago, everybody was only talking about analytical AI, finding the needle in the haystack data-wise. Now everybody seems to be implying large language models, generative AI. And I mean, we know there are still shortcomings. For instance, hallucinations. If I go and look for sort of where do I have dinner in a city I haven't been in, okay, we can afford a bit of hallucination, and I can look at it and see whether that's really what I want. But when it's about how do we operate this critical asset, where human lives may be exposed, where millions of dollars on the operational side and even more on the asset side are exposed, then we can simply not afford hallucination. So the quality of the reasoning, the decision quality, the dependability of the whole thing is paramount. So I think that has a big influence. And look, I personally feel if you look for sort of the wave front of where can you deploy things first. If we're, for instance, into tasks like taking textiles and folding them for packaging, yeah, you can deploy algorithms there, and if the robot makes a mistake, worst case, you have a hole in a t-shirt. As long as you separate that operation from human beings, a hole in a t-shirt is probably an affordable damage. If you get more done and in a more consistent quality. Whereas if this is in mining, in oil and gas, in other mission critical industries, then clearly, no, we cannot afford to play. We have to know and to prove and then to deploy in the field.
Yeah, I'm just going over some of the comments, and I want to remind people at home watching us, wherever you are. So someone was about to board a plane in the beginning when they started watching us. And of course, this conversation is going to be recorded. You can watch it afterwards and replay if you join us late. I want to remind you can also ask questions in the chat for us and Peter. About a point you made earlier, Sebastian made from his point of view, to keep the machine vision system in the control loop. Keeping the machine vision system in the control loop would be a must-have to enable the autonomous machine and process. And I see a lot of comments of asking about different technologies of AI that we might experiment or might have experienced in the past. I know we talked a bit about that, but I want to hear from you a bit more about the role of digital and AI technologies play in the journey towards autonomy. Can you say a bit more about that?
I think what we get is we're getting a much richer toolbox. I mentioned natural language processing, for instance, not an area in which ABB would have to do research, but there's companies that do amazing natural language processing all the way to online translation and so on. So these are ingredients where we can stand on the shoulders of giants, use other people's technology, and yet provide a better experience, obviously ascertaining that things work. Let's also, when we talk about standing on the shoulders of giants, let's not on the foundation side forget cybersecurity. When we're talking about mission critical operations, then cybersecurity is paramount. Otherwise, we cannot trust our digital technology stack. So we have to build that in, and it's to be designed in from the start, and it's to be maintained over the life cycle as both the threat as well as the defense landscapes evolve. Then with the capabilities, if I give you an example from a measurement and analytics business, and you could say, oh, is that not just sensing? Well, no. Take methane emissions that you could have natural gas from pipelines as an example, or from well sites. Those are both a safety hazard. You could have explosions, but they're also an environmental hazard because methane is quite a potent greenhouse gas, more than CO2 is. And what we have is we have analyzers as a product, but we can mount them on cars, we can mount them on drones, and then fly them around, and they can actually, with the help of digital maps, with wind speed measurement, correction for that, they can pinpoint the locations of leaks at a stage where there's simply a hazard, but nothing has happened yet. And you can remedy those, which is great from both a safety as well as a sustainability perspective. So that's just one of the examples where we're using data, where we're using data generated from very specific sensing we have. There's some pretty amazing sensor technologies out there that distinguish also between biogenic, like from a farm, versus thermogenic from a reservoir gas, and then give you this information and make it actionable for your maintenance team to fix the situation before it becomes a problem.
Margarita is asking, what's a realistic first step for companies that feel like they are not ready for autonomy yet?
I think the first is always find out where you are. And then we're very open in the industries we serve for a dialogue with our customers to establish first, where are we really today? And then often it's already on the automation that there are things you can improve. You want to have your base layers right, and then have a dialogue about, so if only we could achieve this, how much would that add in terms of the safety, productivity, or sustainability? I can give you an example, for instance, in marine vessels. If let's say you have a ferry, you're up in Finland, which is actually one of our pilot sites where a few years ago already we went with that. And Finland in the winter when it's raining is about as difficult as it gets if you want to land a ferry. So then actually human beings and certainly my own eyesight wouldn't be good enough to even see what's going on, let alone if there's an obstacle or a person, an animal in the way in the water. But technology can actually see under those conditions. So if you can then deploy technology to augment your senses, if you can process those images, then you can actually automate that docking maneuver. And that's just one example of understanding, okay, here we have a particular challenge and technology is available today to overcome those hurdles.
Just a comment, Alexandra is saying that by using AI, humanity must not forget that not everything should be left to robotics. You have talked a bit about autonomous cars, for example, something we've all seen some videos, and we've seen this technology being how it looks in real life. I want to ask you a bit about predictions. We are hearing a lot of predictions, and I think maybe I want to hear from you about what you think from, I would say around our industry that we are hearing that might not be realistic, let's say for the next 10 years. Of course, as much as you can tell us a bit about your opinion about that.
No, I think we get a storm of emotions perhaps in the chat. But one of the areas where I think the industry, people that I'm interacting with are less optimistic than the general public is humanoid robots solving everything in the next few years.
Because we're seeing quite a lot of this recently.
Yeah, there's a lot of them out there. We ourselves, I recall about 15 years ago, we actually came out with the first pilot projects with Yumi collaborative robot portfolio, like a humanoid upper body, takes the robot out of the cage, because it safely interacts with human beings. I recall at the time we demonstrated it at Hanover Fair 2011, and Angela Merkel was actually curious to see how this works. Without sort of talking with anyone, suddenly put her arm forward, stuck her finger in. Everybody was a bit nervous, but the robot was actually as human-friendly as it was supposed to be. So we didn't make headlines in those days, and I'm happy about it. But if you look, we've been in this for quite some time. We've solved a few problems, but at the same time, if you look, those humanoid robots that you see on YouTube videos, there's a lot of them. Some of them are looking quite elegant today, but when you really expose them to everyday situations, when you really look at the question of how long does their battery last, how dangerous or safe is it if they would fall over with the sort of masses and sizes we would need in applications, then very quickly you get to obstacles that don't make me too optimistic that in the next 10 years something big is going to be achieved there. At the same time, I think beyond technology, and I commented on some of that already, beyond technology, necessity remains a mother of invention. So it's not always been the most perceived high-tech industries that have moved the fastest, but we've seen industries where people were just out there in difficult places. So the pressure on the industry to provide expertise, to provide solutions, either in terms of not having crew out in those places, or then a second best to have minimum crewing and maximum technology support. Take mining up in the Andes above 4,000 meters, really difficult conditions, but rich ore bodies for copper, as an example. The world needs copper. So them being able to support that out of operation centers more than 1,000 kilometers away so that you can live with minimum crewing out on the mine asset is important. Same thing with offshore oil and gas industry. So I think it's going to be a combination of technology push and the growing stack. I'm super excited about that technology stack and how it's growing, together with the pull for making industries outrun leaner and cleaner.
Very important. Look, we're getting towards the end, and I think that I'm looking also at the questions. I'm sorry if we didn't manage to get to everyone today. There's quite a lot of them, and a lot of them are about predictions. In the end of the day, and of your vision and ABB's vision when it comes to automation, what is the one, I would say, practical takeaway you would want people to leave the conversation today with?
First of all, I think there couldn't be a more exciting time to be in this journey towards autonomous operations. We've used it as a headline. It's been a theme in my customer engagements for the last 10 or so years. And I think it easily has another 10 or so years to run. We will continue to make progress, but I don't believe we will see the one silver bullet that solves the problem of autonomy once and for all and for everybody. I think really understanding the challenges we're tackling, understanding the tools we have in the toolbox, and then building the bridge together so we can walk over it. That's going to be the solution. So I don't bet on a single technology, but I think it's interesting to follow these. There's a lot of good analysis out there. I personally, for instance, every year look at the updates Rodney Brooks, former MIT robotics and AI lab head, continues to push out there.
Say something about him. I mean, you mentioned to me before we conversation about him, and I was Googling a bit to understand a bit more.
I think he's an amazing, one of the many amazing personalities in this field. But if there's one blog that I certainly look at least once per year, it's kind of his views on where's autonomy going, the self-driving car. He's recently added a few other forecasts. So rather than venturing out on too many of my own, he's basically keeping a tab on what have automotive industry CEOs made in terms of commitments out there. How are they tracking? He's adding some of his own. So I think for anyone interested in the subject, because beyond just looking at what can my industry do together with ABB, I think for the broader subject, I think this is really recommended reading, and I'm always interested in his views.
Sounds great. Thank you very much, Peter. Thank you very much for everyone for joining us today on a Friday afternoon here in our office in Zurich. Please join us for our next few live stream. We're going to discuss similar topics, also relevant for your industry, for ABB. And thank you very much, Peter, for joining us today. Thank you for your time.
My pleasure. Thank you.
Thank you. Thank you, everyone.